The only other way we can use the equation that we were given here in section 8.3 is to calculate time. Time for us to get an annuity to a certain level for us to cash it out. Now, in this case, we rely on the fact that we'll know what the payment we're making is. We'll need to know the number of compounds in a year. We'll need to know what the final amount we're trying to achieve is. And we need to know what the interest rate. And if we have that, then here is an alternate equation. Now, you won't find this equation in your book. It is derived from our A equals R equation. I like to call this one the argon-nurse equation, simply because we see AR, which is the periodic symbol for argon, and we see RN, which is registered nurse. So I like to call this the argon-nurse equation. Helps me give it a name. Now, to do this, it's kind of complicated, but again, we just put the elements in and our calculator will do all the brunt work. All right, I assure you that's what's going to happen. But first, what we're going to do is we're going to take A times R, as in the interest rate. We're going to divide that by the payments times the number of compounds in a year. We're going to add 1 to that, and then we're going to take the natural log of it. And then we're going to divide that whole thing by the natural log of 1 plus R over N. We've seen that before. And then we're going to take that whole thing and divide it by the number of compounds in the year. And that's going to tell us the time it takes for an investment to grow to a level that we want to grow it to. All right, so let's go ahead and minimize our equation here a little bit. You know what we don't need? We don't need our other equation here anymore, so we'll get rid of that. All right, and we're ready to rock and roll. Example 3 says, suppose you have decided to retire as soon as you save $1 million. All right, so that looks like our A value. So let's just start writing our values in as we come across them. Our A value is 1 with 6 zeros on it. Your plan is to put $200 each month. All right, that sounds like a payment. It also sounds like an N value, as in each month, that's 12 times. Into an ordinary annuity that pays an annual interest rate of 8%. Ooh, there's the R value, little r value, 0.08, 8%. And how many years will you be able to retire? So the T value is what they're looking for. I know T to be a drink with jam and bread, if you believe the old song. In this case, that's not it, but it is going to be a number of years. And so let's set up our equation so we can solve for it. Let's start right here. So we know that T is equal to the natural log of 1,000,000, 1, 2, 3, 4, 5, 6 zeros, times little r, so times 0.08, divided by big R, 200, times our N value, which we know is 12. And then this is going to be plus 1. Close that piece out. Divided by the natural log of 1 plus 0.08 divided by 12. And then this whole thing is getting divided by 12. So this is one big equation in our numerator of this big giant fraction here. Let's use a rounded parenthesis to show that. Again, our calculator is going to do all the brunt work for us. It's just a matter of setting it up correctly so that it does. So let's bring that calculator up and talk through this. All right, so the first thing we're going to do is we're going to start at the top and we're going to take 1,000,000 times 0.08. So 1 with 6 zeros. 1, 2, 3, 4, 5, 6 times 0.08. Enter. All right, so we've got that value. We need to take that value and we need to divide it by 200 times 12. So we're going to say divided by, we're going to use those parentheses again, and we're going to say 200 times 12. End parenthesis. Enter. All right, so what we now have is this part of it. So now our next part is to say plus 1. Fairly easy enough. Plus 1. Enter. Now we want to take the natural log of this. Remember, you could take log as well, but I like the natural log myself. So I'm going to hit the ln button on my calculator. Now I need to put this number into it. And once again, I could type it, but why? Use the power of your calculator. So second minus button, which is the ands, which basically means do the log or natural log of this 34.33333. Then we say divided by, And we do a natural log again because this is a natural log right here. And the beauty of this calculator is it will do it just as you type it. So we can actually just type in this entire parenthesis here. So we've got the parenthesis started, and it says 1 plus 0.08 divided by 12. Now, thankfully, our calculator has been programmed with the order of operations. In other words, it will do 0.08 divided by 12 and then add it to 1, so we don't have to worry about that. But let's go ahead and hit enter now, because now our numerator of this giant fraction is known. It's 532. So the final thing for us is to say divided by 12. So we'll say divided by 12. And the answer is going to be 44.348, etc. So it tells us that it's going to take us 44 years of making $200 payments into this annuity in order for us to achieve $1 million. That seems like a long time for us to get $1 million, especially when we're getting an 8% interest rate. That's pretty high. But 44 years and we'll have $1 million. Is it worth it? I'll leave that up for you to decide.